Falcon 9 and Crew Dragon, go NASA, go SpaceX, Godspeed, Bob and Doug. America has launched.
All right, this is a launch of a rocket, and the speed of the rocket is actually increasing, so which means this rocket is actually accelerating. It's getting faster, or else it will not be able to escape the gravity of the Earth. So it's getting faster. And now let's come back to this question. Question 14. All right, question number 14. It says that you have this rocket. It's being launched, and the height is actually the distance, right? The length, the distance traveled. So the distance is a function of time, equals to 20t squared. So as the time goes by, your distance travel will increase exponentially. However, because time must be positive, so this parabola only have the t has to be positive. So the negative part is I covered. And a very important concept that you must know is that speed is actually the derivative of distance, which means, in other words, is speed is the gradient of your distance time graph. Okay, so the graph that we just plotted over here, this is a distance time graph, distance height time graph. And the gradient of this curve represents the speed, how fast this rocket is traveling. The gradient is the speed. So what is the gradient? What is the derivative? The derivative of 20t squared is actually 40t. Okay? And the question says, find the height and the speed of a rocket when the time is 150 seconds. So at 150 seconds, what is your position? You simply sub this value back to the original equation. Then you find out it is 450,000 meters. So at 150 seconds, your rocket will be 450,000 meters away from the Earth. And then the question asks you, at that time, at 150 seconds, what will be the speed of the rocket? You sub the 150 into the second equation, which is the derivative 40t, because the derivative is the speed. Therefore, you get 6,000. So at 150 seconds, the rocket is traveling at a speed of 6,000 meters per second, which means every 1 second, the rocket travels 6 kilometers. And that is fast, by the way. Now, the question is asking, after how long will its speed be 1,000 meters per second? So now we know that the formula, the derivative is 40t for speed. So this is a function. And at what time will the speed increase until 1,000 meters per second? 1,000 meters per second is 1 kilometer per second. Because the speed of a rocket is not, in the very beginning, it's already so fast. At first, the rocket was not moving at all. So it was accelerating. As you can see from the movie, it's accelerating, getting faster and faster and faster. So from this equation, we can find out that at 25th second, the speed of the rocket will reach 1,000 meters per second. Okay?